In the previous episode, we discussed the kind of reasoning that should be done by a robocop observing a masked gentleman crawling out of a broken shop window with a bag full of expensive jewelry. We arrived at the conclusion that such an observation should increase the plausibility of a claim about the gentleman's dishonesty. But we stopped at the question of how artificial general intelligence, or AGI, is going to measure this plausibility in the real-world scenarios of incomplete information so that, among other things, we too can know what AGI is thinking. Thank you for listening and subscribing. I am Alex Chaduk and this is AGI. Listen every Monday morning on your favorite podcast platform. Whether we should measure plausibility is not a trivial question to ask if you think about it. In contrast to logical reasoning, the discipline of plausible reasoning spent a very long time in our historic past in the domain of metaphysics. Remember our recent discussion of AGI finding God, which is our shorthand for how a rational intelligent system should manage the line between its physics, which is its internally consistent world model, and its metaphysics, that answers the questions like, what is real? Or, when should I stop asking questions and do something with the limited information I already have? Our claim is that these kinds of metaphysics will always be present in an intelligent system at any level of complexity. The more complex AGI, the more intricate will be its internally consistent world model, and even more elaborate will become its metaphysics, dealing with ever more complex questions of ethics, reality, societal goals, or search for truth and meaning. An AGI system that dedicates time to thinking through the implications of its own metaphysics will discover new internal regularities within them. Such thinking will allow it to formalize these regularities and eventually integrate them into its world model. Colloquially, we call this integration a scientific discovery. It moves the boundary between physics and metaphysics, expanding our world model. At the same time, it allows us to consider ever more elaborate metaphysical questions, querying further and further into the vast unknown of our universe. We may not appreciate this now when computation drives a significant part of our everyday reality, but merely 200 years ago, plausible reasoning was more of a skillful art than science. It would be akin to our today's ability to judge whether a good theater play or a movie presents a credible story. Only in the case of the old-time plausible reasoning, the judgments were passed about the real world. But the general public did not feel that any precise measurement was necessary, so plausible reasoning remained a part of metaphysics. Not that mathematicians did not try to measure it. At the beginning of the 18th century, Jacob Bernoulli, in his appropriately named book Art of Conjecture, argued that the degree of our confidence in the statements in which we do not have absolute certainty should be measured the same way that we measure games of chance, that is, by employing the calculus of probability. The obvious disconnect was that probability measured the games of dice or playing cards that could be repeated and observed many times. The uncertain statements, on the other hand, described events that either went unobserved or did not even happen, like, for example, uncertain predictions of the future. So Bernoulli's proposal to measure them with the same measure of probability was impossible to justify logically, and so his proposal remained within the domain of metaphysics, meaning that it was really a matter of personal taste, whether you wanted to believe that or not. Many mathematicians did not want to take it on faith and tried to invent various new calculuses, or, as the proper plural goes, calculi to measure the plausibility of assertions with varying degrees of success. But their problem was not with the logical reasoning within each individual calculus. It was fairly easy to follow the logic of any individual conclusion, very much like we followed the conclusions that the robocop had to make about the masked gentleman in the previous episode. The problem with the competing calculi of plausibility was that, as we already know, each one of them had to start somewhere from some initial set of metaphysics or axioms that had to be taken for granted without proof. The crux of the problem was the lack of consensus within the mathematical community on what we can or cannot take for granted when measuring plausibility of uncertain statements. It was not until 1961 when Richard Cox, a physicist at the Johns Hopkins University, unraveled this mystery. How? We will find out in the next episode. With this, until next Monday, my friends, I am Alex Chaduk, and this is AGI.